Good day, everybody. I am Brian's friend Xavier from BSME 3D, and I'm going to discuss speed and torque, types of direct current generators, and some problem solving. So, onting ano lang sa speed and torque. Speed is a speed of rotation of armature direct current of the motor. So, dito pinag-aralan natin yung mabilis ng armature sa direct current motor na ang unit niya is RPM, which is rad per minute. Next is torque. Moment of force is the tendency of a force to rotate or move an object about an axis. A force is a push or pull. Likewise, torque is a twist to an object mathematically. Torque is force times R. So ito yung parang moment siya ng force na na makikita natin sa kadalasan sa mga machinery. Siya yung parang nagbibigay lakas o yung dumadagdag sa force. Next is types of direct current generators. So, onting review lang. A direct current motor is a type of electrical machine that converts electrical energy into mechanical energy. DC motors take electrical power through direct current and converts this energy into mechanical rotation. So, kagaya sa dati nating mga pinag-aralan, iyan yung pag umiikot siya, yan, yung gamit yung mga magnets or electromagnets is nagbibigay siya ng mechanical energy. Ito rin yung mga ginagamit kadalasan sa mga sa pang araw-araw natin sa ilaw, ganun. Next is, ito na yung types of direct current generators. First is the permanent magnet DC generator. It's a kind of power generation device which transforms mechanical energy into electrical energy. It's a kind of permanent magnet DC generator with double permanent magnet and double winding structure. So, yun nga yung parang yung sinabi ko lang kanina, yung nag-convert siya ng yung kanina is electrical to mechanical. Ito naman, power generator na nag-transform ng mechanical to electrical energy. Ito daw ay may permanent magnet. These are generators with double permanent magnet and double winding structures. Next is separated excited direct current generator. It's the one whose field windings is supplied by an independent external DC generator like a battery. So, yung kanina is yung parang sa kuryente natin, which is mayroon siyang permanent magnet na kumbaga is tuloy-tuloy lang siya. Ito naman is meron siyang external source katulad ng mga batteries. Self-excited DC generators are generators whose field magnet are energized by current supplied by themselves. In this type of machine, field coils are internally connected with an armature due residual magnetism. Some flux is always present in the poles. So, ito yung kumbaga is sinusupply nila yung sarili nila yung ito yung nangyayari sa parang electric fan. Pero hindi pala. Ito yung parang mangyayari sa water wheel, yung tuloy-tuloy lang yung pag-ikot niya at tuloy-tuloy lang din yung niya ng electricity gamit yung patuloy na rotation na nanggagaling doon sa water wheel. Next is types of self-excited direct current generators. And types of self-excited direct current generators is series wound generators. It's used principally to supply and constant current of variable voltage. If a motor or generator is series wound, it has a field armature circuits connected in a series. So ito daw yung nagsusupply ng current na constant current at variable voltage. Next is the shunt wound generators. As a field of armature circuits connected in a parallel. Current in the field windings in shunt wound generators independent of the load current because the current is a parallel branch are independent from each other. So kung yung nauna is yun connected siya in series, ito naman connected in parallel, at dahil connected siya by parallel ay parang mas independent siya dun sa load, independent dun sa load current, ay gagana siya kahit sometimes gagana siya kahit wala yung load current. Sa pang example is yung compound wound generators have both series field windings and shunt field windings. One windings is placed in series with the armature is placed with the kumbaga ito yung pinaghalong shunt saka pinaghalong series wound. Meron siyang parehas na series at meron siyang parehas na shunt, which is parang nakukuha niya yung dalawa. Pwede siya maging pwede siyang maging independent, pwedeng ano siya sa load voltage. Types of compound wound DC generators. Short shunt compound wound generators. Only the shunt field windings is in parallel with the armature windings. So isa is long shunt, which is parallel with the series field and armature windings. Then problem solving. This topic is given by our prof. Problem number 1. A 4-pole generator has 50 conductors on an armature. If the generator is running at 1,200 RPM, find the average voltage generated between brushes for A, a lap winding, and B, a wave winding. The total flux per pole is 1 times 10 raised to 6. So here's the given. Meron P, number of poles, meron siyang 4 poles. A, which is the number of armature, meron siyang 4. The Z, which is number of conductors, is 500. N is the speed of armature rotations. Ayan, unit niya is RPM. Then the number of flux per pole is 1 times 10 raised to 6. So, paano ba ang gagawin dito? Yan, gagamitin natin yung formula ng back EMF, yung P multiply number of poles multiplied by flux per pole multiplied by the armature rotations speed, the speed of armature rotations multiplied by the number of conductors divided by 60 multiplied by number of armature times 10 raised to 6. So yan, sa-substitute lang natin yung mga given na numbers, substitute lang natin siya sa formula, which is yung P is 4, yung number of, yung flux is 1 times 10 to raise to 6, N is 1, 2 RPM, and yung number of conductors is 500, which is yung Z, then 60 over 4, which is yung A, then times 1 raised to 6 naman, mali lang ng lagay. Then, pag nilagay sa calculator, makikita natin is 100 volts ang makukuha nating back EMF. Next is, ganun lang din. Wave winding naman ang kukunin natin. Pero dito is, nagbago yung flux niya, which is 1 times 10 raised to 8, and then yung A niya is 2. So, isa-substitute lang din natin yung formula. And substitute lang natin yung given dun sa, andun sa formula, yung given dun sa formula. Yan. Then, makuha natin is 200 volts. So, problem number 2. A short shunt compound generator has a full load current of 60 ampere. If the series field resistance is 0.04 ohms and a diverter carries 24 amp, what is the diverter resistance? So, ito yung given, which is yung I sub L, which is the load current, R sub SE, which is the series field winding resistance, and the ID yung the diverter. So, yun yung load current meron 60 ampere, RSE 0.04 ohms, and then yung diverter meron siyang 24 amp. Then, paano ba siya i-solve? So, ang hinahanap natin dito is yung resistance ng diverter. Paano siya i-solve? Yan, ang resistance of diverter is ISE, I sub SE multiplied by R sub SE divided by ID. Yung RSE, which is yung series field winding resistance, ay meron na tayo sa yung diverter. But wala pa tayong value ng I sub SE, which is yung current in the series field. So, paano ba i-solve yung current in the series field? Ang formula niya is ito, which is IL, which is yung load current, is equal to the diverter plus the current in series field. So, substitute lang natin yung meron tayong value, which is yung I sub L sa yung I sub D, which is 60 and 24. So, pag kinumpit natin dyan is ISE is equal to 60 minus 24. So, ang ISE natin or ang current in the series field is 36 ampere. So, ayun, kompleto na yung ating kailangan para makuha natin yung load current o yung resistance diverter para makuha natin yung R sub D. So, ayan, substitute lang natin yung mga given na, which yung I sub SE or yung current in the series field, may nakuha tayong 36 multiplied by the RSE, which is yung series field winding resistance na 0.04 divided by the diverter, which is 24 ampere. So, pag kinumpit natin ito, makukuha natin is 0.06 ohms. Problem number 3. A short shunt compound generator has a shunt field resistance of 77 ohms, a series field resistance of 0.008 ohms, communicating pole winding resistance of 0.005 ohms, and an armature resistance, including brushes of 0.02 ohms. When the armature current is 128 ampere, the generated EMF is 234 234.2 volts. Calculate the power delivered. So, ang hinahanap natin dito is yung power delivered. Ayun, makikita natin dito sa gilid, yun yung mga given, then yung kung ano siya, RF, which is yung shunt field resistance, RSE, series field winding resistance, RA, R sub A, total resistance armature, R sub C, communicating pole winding resistance, I sub A, armature current, and EG, generated EMF. So, yan din yung given nila. R sub F is 77 ohms. R sub SE is equal to 0.008 ohms. R sub A is 0.02. R sub C is 0.005. I sub A is 128 ampere. And din yung generated EMF is 234.2 volts. So, ang hinahanap natin dito is yung P sub L, which is yung power delivered. So, ano ang kailangan natin sa power? Ito yung, ano niya, yung formula niya, which is yung IL, which is yung load current, and multiplied by the V sub T, which is yung terminal voltage. Pero wala tayong, anong parehas, yung, load, wala tayong value ng load current and terminal voltage. So, paano ba isolve yun? To get the terminal voltage, and generated EMF, which is 234.2, then VT plus I sub A, which is yung armature current, which is 128, multiplied by the RA, or yung total resistance, plus RC, yung communicating pole windings. So, yun, substitute lang natin yung mga given natin, ay mga given value, then makukuha na natin yung VT, which is 231 volts. So, meron tayong VT. Ang kulang na lang is yung I sub L, which is yung load current. To get the load current, IL is equal to I sub A minus I sub F, which is ang I sub A natin is 128 ampere. And yung I sub F natin is, yun, wala rin tayong value ng I sub F, at ang formula niya is VT minus V sub T all over, V sub T over R sub F, which is yung shunt field resistance. So, substitute lang natin 128, then 231, minus 231 over 77. Ang makakuha nating load current is 125 ampere. So, yun, kompleto na yung kailangan natin para makuha yung power na delivered, which is yung I sub L of multiplied by VT, or load current, multiplied by terminal voltage 125, multiplied by 231, makuha natin is 28.8 kilowatts. So, yun, pag in-enter natin siya sa calcu natin, hindi naman 28.8 ang lalabas. 125 times 231. So, yan, ang lalabas is 28,875 watts. Watts yun. So, convert lang natin siya sa kilowatts para mapaikli natin yung ating sagot, which is i-divide natin siya sa 1,000. Yan, magiging 28.8 kilowatts. Then, yan, problem solving number 4. A 5 kilowatt 120 volts compound generator has an armature resistance of 0.25 ohms, a series field resistance of 0.04 ohms, and a shunt field resistance of 57.5 ohms. Assuming a long shunt connection and a voltage drop at the brushes of 2 volts, Calculate the generated EMF at full load. Pwede given niya P, which is yung power, 5 kilowatts. VT, terminal voltage, 120 volts. RA, total resistance of armature, which is 0.23 ohms. RSE, which is 0.04. R sub F, with shunt field resistance, 57.5 ohms. And PPC, which is brush contact voltage drop, which is 2 volts. So, paano ba ito kunin? Ayan yung EG, ang ating kunin, which is yung generated voltage. Ayan, at ito ang kanyang formula. EG is equal to VT plus IA multiplied by IA multiplied by RA plus RSE plus VBC. So yung IA ay may formula siya na katulad sa kanina nating sa number 3, ang formula ng IA is IF plus IL. So yan na, substitute ko lang yung formula, then sasolve natin yung I sub L, which is yung load current. So yan, IL is equal to P sub L all over VT. Ay yung P sub L natin, which yun din yung power natin. So, ayan, P sub L, ayan, nakikita natin is 5 kilowatts siya. So, multiply natin siya sa 1,000 at watts ang ginagamit natin dito. Kaya 5,000 watts all over 120 volts, which is yung voltage. Ang makuha natin is 41.67 ampere. So, solve for I sub F. And I sub F is equal to V sub T all over R sub F, which is, yan, yung V sub T natin is 120 volts. And yung R sub F natin is 57.5 ohms. And pag ginumpin natin yan is makuha natin is 2.087 ampere. So yan, meron na uli na tayong lahat. Nung meron tayong EG, meron tayong VT, meron tayong IF and IL, yung makuha natin sa para makuha yung I sub A. Then meron tayong RA, meron tayong RSN, meron tayong V sub BC. Yan, sa substitute lang natin yung mga formula, mga given values sa formula. Ayan. At pag kinumpit natin to, ang makuha natin is 133.8 volts. So yun lang, maraming salamat sa pakikinig at peace.